Hello friends, in this video I'd like to solve the following problem from the Indian Mathematical Olympiad 2005, problem number 6. We wish to find all functions for f from the set of real numbers into itself, such that f of x squared plus y times f of z equals x times f of x plus z times f of y for all real numbers x, y, and z. So here are my hints for this problem. Notice that function which is constantly 0 obviously satisfies our equation. So suppose that our function is not constantly 0, so f of y sub naught y0 is not 0 for some y sub 0. Then try setting x to be 0 and y to be y0 and demonstrate that our function f must be injective. Finally, set z to be equal y and notice that the left-hand side of our equation becomes symmetric, and use this symmetry. So give this problem a try and I will see you in just a minute. Okay, so let's start with noticing that if f equals 0 constantly, then f satisfies, I will call my condition asterisk. So now, suppose now that that there is y sub 0, a real number, such that f of y sub 0 is not 0, that our function is not constantly 0. And now I wish to set x to be 0, and I wish to set my y to be y sub 0. And after that, asterisk becomes, after this substitution, becomes what exactly? Let's take a look. We have f of y sub 0 f of z equals 0 plus z times f of y0. And notice that the right-hand side, as a function of z, since it's a linear function which is not constant, this function is a bijection. But I only need injectivity. So let's write is injective. It's injective. So the function on the left-hand side must also be injective. But by a well-known property, composition of two functions is injective. If it is injective, then the inner function must be injective. So now we know that function which takes z and maps it to y0 f of z, this inner function must be injective as well. Must be injective as well. Well, but since this function is injective, we see that y sub 0 must not be 0, and more importantly, f itself must be injective. So let's write it in other shade of green, and f must be injective. Very crucial. We'll use it in a minute. It's so crucial that I will call it double asterisk. Okay, now let's set another variables. Now let's set z to be equal y in our very first equation. Our functional equation asterisk becomes the following. Let's take a look. Y equals z, or z equals y. So we have f of x squared plus y times f of y equals x times f of x plus y times f of y. Is it right? Yes, it is. But now let's notice that the right hand side is symmetric with respect to x and y. So because of symmetry, I can change y and x to get the following. This middle term equals f of y squared plus x times f of x. That's it. And now I will take these two functions which are here and here written in pink. Now I will use the fact that my function is injective. Since f is injective, or maybe let's write it shorter, by double asterisk, by injectivity, I know that x squared plus y times f of y equals y squared plus x times f of x. Very well. And now let's set y to be 0. Let's set y to be 0, and we get the following. X squared equals x times f of x. Very well, and now we can divide by x, but remember that we cannot divide by 0, so we can safely say that for every real number, but not for 0, f of x equals x. Okay, but now let's notice what is f of 0. Well, since f of x equals x, and it's for every x which is non-zero, and since f is injective, well, what is f of 0? F of 0 must be also equal to 0. Well, why is that? Well, because every other value is attained for other x, and our function is injective, so the same x cannot be attained twice. So the only value not attained yet by our function is 0 itself. So now we know that for every i.e., let's write it in pink. Now we know that, in fact, for every real number x, f of x is equal x. And now we should do the verification, but verification is very, very trivial. But I will do it anyway. Verification. Left-hand side, our left-hand side, we have, let's go back, we have what exactly? F of x squared plus y times f of z. But since our function is just identity, it's x squared plus y times z. And what happens on the right hand side? We have x times f of x plus z times f of y. And we see that in fact it is equal. So all in all, we have two solutions, and I need some space. I don't want to start a new page, so I will put everything a bit higher. So our solutions, in fact, we have only two solutions, either f of x equals 0 for every x, or f of x just equals x for every x. And that is it. We have exactly two solutions. Thank you for watching, and I will see you next time. Goodbye.